Hello and welcome to the 5th Solfem 3 tutorial. In this tutorial we will create a simple two-dimensional mesh from scratch. So let's start by opening up a terminal window and navigating to the Solfem v3 work directory. Here we start up the script program.py and we select the viewer. Now when we build a mesh from scratch, of course we have to first create a new mesh, and we start with one element, so it will be a quad 4 element. These are the only elements you can create from scratch in Solfem v3, and you can then later convert these into other elements. So for example, this element can be converted to an 8-node quad element, or two triangular 3-node elements, or two triangular 6-node elements. So here you can see what that looks like. But when you are creating your mesh, you will be working with quad elements, or quad 4 elements, or hex 8 elements. Of course, beam elements and rod elements are just 2 nodes, so that's you can, yeah, we already did tutorials for those. Those are simpler. But we will start with this one element, and first let's extrude the element. That's the extrude button up here. Let's extrude it 2 elements, so in the X direction. So now we have 3 elements, and they are well, they have a element size 1 in each direction. So now we have here 3. The length is 3 here, and we're working in millimeters, so 3 millimeters. And now let's extrude in the -1 direction, in the negative y direction, so the vector 0, -1, 0. And we want 29 elements, and it's a straight down extrusion. Okay, and let's do something slightly more complicated now. We will extrude downwards with an angle. So same as before, we type in the vector here 0, -1, 0 to extrude downwards, and let's extrude 16 elements at an angle 180 degrees, and we're extruding around the set axis, so it will be extruding clockwise now. No, counterclockwise. and set the radius to 6. And there we go. Maybe that was maybe the size difference is a bit too much. Maybe let's just delete them and try again. Angled 0, -1, 0 there, and we tried 16. Let's try let's try 14. 180 degrees, and the radius, we set that to 6. Looks a little bit better. Yeah. And no, actually this is too narrow. Let's try it one more time. Angled -1, 0, -1, 0 there. Extrude number, it was let's stick to 16. 180, and this will be clockwise, no, counterclockwise, and instead of 6 let's use 8. Yeah, I like this a little bit better. Now if I try to extrude these straight up, the extrusion will assume it will take the element size from one of these elements, so it will not extrude the same size as these, which are exactly 1. So instead of doing that, I'll just copy these elements right here. Let's just see. The distance here between these two nodes is 13. And if I copy these, and I will copy them with an offset vector 13, 0, 0. So now these 4 elements are, they're basically they're loose, they're not attached here, so we will have to fuse nodes. And what happens then is the nodes, all of the nodes, I selected all the nodes in this area, and there were nodes on these elements and on these elements. They were separate nodes, but I selected all of them and fused them. And as you can see down here, what happens when you fuse nodes is that the nodes that become obsolete are removed. So now instead of 8 nodes, there are only 4 nodes here. So that's as we wanted. Now we will extrude this one, I think. And we will extrude it upwards at an angle. We will extrude 8. So we're doing half of the previous extrusion. And now we are extruding the other way, so we have to change the axis so it goes clockwise. And the radius was 8, if I remember correctly. Here we go. Maybe it wasn't 8, maybe it was it 6? It looks a bit too big. We'll try again. We'll extrude at an angle. Whoops. Straight up at an angle, and it was 8 elements. No, yeah, 8. 90 degrees. And let's try 6. There we go. That looks better. And again, same as before, if I try to extrude these, it will not get the same size as these, which is what I want. So what I can do is, well, let's first check the distance here. The distance is 20 down here. So I'll first select these and copy elements, and the offset was 20, so now it copies them and moves the copies 20, a distance of 20 to the right. Okay, and same as before, here we now have 8 nodes. So four nodes on these 3 elements and 4 on these 3 elements. And I just selected all of them. So I've just selected 8 nodes, and I'm going to fuse any nodes that are within the tolerance, the distance from each other. And there we go. It deleted the four of the nodes, so now there are only 4 nodes here. And let's extrude this 5 more straight in the X direction. Yes, sure, this looks good. It's like a small spring of some kind, and we're going to obviously there's a lot of bending here, so we should probably be working in 8 second order quadratic elements. So let's convert. First we select the elements, and then we convert them. So this is something you do after you have finished building your mesh, because if you convert them, you can no longer extrude. You can't extrude quadratic 8 node elements, only quadratic 4 node elements. And after you've converted them, you can't convert back. So wait until your mesh is finished and then you convert. Actually, while we're building mesh like this, I should probably say that you can always save your progress up here. I can just show you how it's done. Tutorial 5 and save. Now it's saved, and it's saved as a MDL file, so a model file. And if I run into a problem, I do something wrong and everything is, all my progress, I can't take it back, then I can just start up the program again, or clear out. If you click this new button, it will clear out everything and you can start fresh, and then you can open your previous save. but we have not made any serious mistakes here now, so we'll just keep going. Now let's select these nodes. Use shift and drag select. Hold down shift to select more elements, and we'll give this node set number 1. This one, these nodes up here can be node set number 2, and down here we will have node set number 3. So we also need an element set number 1. Very good. And then next our elements need properties, so we'll click the create section button, and we're gonna use, let's use stainless steel. And these are 2D elements, so now we have to specify the thickness. And let's say 15 millimeters. Okay. And we have our section, so we click the apply section, because now we have created our section and we have the element set, all of the elements. So notice now when I apply, this should change to applied, meaning all elements now have section properties. And we are ready to create our solution, so we'll click the static button. We can call it solution 1, no need to change, and we're going to apply displacement boundary conditions. So we'll lock the node set 1 in the x direction, like that, and click this current solution button to show these show the solution with the boundary condition in the viewer here. We can see the boundary conditions here, and we want also on node set number 2 in the y direction, so that's degree of freedom 2, 0 displacement. Okay, and now we can apply a uniform force. So this is a small spring type of thing. It's pretty thin, 3 millimeters, so not much force happening here. Let's try 20 newtons, and we can do it 45 degrees upwards here, or let's try a little bit of an angle there. See how that goes. And yeah, node set number 3, and there we go. So that's everything we need for our solution. We can now write the sol file. Just keep the name or change it if you want. And we don't need element force is not available for these 2D elements, and node force is well, we can have a look. Doesn't hurt. Stress and strain, it's basically the same thing. So yeah, or I mean, it's not the same thing, but they look the same. Stress is just strain, well, stress is derived from strain, so it will look exactly the same with different just number values. Anyway, we write the solution file, sol file 1, and we can now click the run solution file in solver, select the solution file and open, and it runs through the solver. 1466 degrees of freedom. And then we open the sol file 1 out file. New results available, solution 1, displacement, stress, node force. So we can now click this current result button and have a look at the displacements, and they look pretty much as we expect. Very little displacement though, so if this is supposed to be a spring, then it's not moving a lot. Let's have a look at the stresses. The stresses are 25, so that's pretty low, but the displacements were also very low. Well, anyway, this doesn't have to be this does not have to be very realistic. We're just showing how the program works. Now in this case it didn't really matter if you have a plane strain or not. The stresses are the same anyway. But if you do want to have a plane strain instead of plane stress, then you type it in here. So now you know that if you want that. And I think that does it for this tutorial. I hope you found it useful. Now you can create some basic simple 2D meshes and apply solutions to them if you want. So thank you for watching, and have fun.